to 8 sine omega t minus kx two traveling waves of same speed and frequency moving opposite to each other of different amplitude undergo superposition. So what we have to find out, find first one, equation for resultant wave. Next time, maximum of antinodes, V max and V minimum of nodes of power flowing through the node, net power flowing through a node, or energy flowing per second through a node. This one. Then energy of a energy in one loop. Okay, very good question. I just brought all the theoretical things. Now what we have, earlier I took some phase, no? Here I took two traveling waves which are moving opposite each other. They're having different amplitude, given 8 centimeter, 6 centimeter amplitude. So they'll undergo superposition. Now it's asking what is the equation for resultant wave. Then what are maximum minimum speed of antinode, maximum minimum speed of nodes, then net power flowing through the node, then energy in one loop. Very good question for students. It's a very, very important thing. Okay, let's do one thing. We'll start with the superposition idea. What is y? Y equal to y1 plus y2. So this should be equal to 8 sine omega t minus kx, 6 sine okay, this one 8. So how to simplify this? Next question comes. So some of you are getting confusion, sir, what is this? Okay, I'll do one thing. This is the meaning of this one. So this is y1. That's all, no? So you need not to bother. There's a string. It is maintained at tension, let T be the tension, the string, whatever it's needed. Let's get into the. So shall I simplify? Shall I write this 8 as 6 plus 2? Okay, 6 plus 6. This will become 12 cos kx sine omega t. Okay, what is this? This is a standing wave. And I do get this is a traveling wave. Now in this region, what we have both standing wave as well as traveling wave. So how do how do this string will appear now? How do this string will appear? So if you look at this string, it will be just again, this is for our convenient. So the standing wave I'll show by this is only diagrammatic representation. Next, we have here a traveling wave. Under action of these two, the string will undergo the superposition. So there's a traveling wave. So what is this? This one, traveling wave, and this is standing wave. So I think this is not a pure standing wave. No, what we earlier discussed, it was only pure standing wave. No, both standing wave as well as traveling wave is also present. Now some students will ask, sir, why you are doing 6 plus 2? Why don't you write 6 as 8 minus 2? Any problem? Student, instead of this simplification, or you may do like this also, no? This 6, can you write? Anybody value simplification of this? 16 will come. This is a standing wave. This is a traveling wave. Okay, now we have a paradox here. What to do now? One student writes this as 6 plus 2. Another student mathematically write, I think both are correct, no? There's no problem mathematically, am I right? Is this okay? Or shall I put negative sign? Anybody please respond? Okay, now what is wrong? Who is right? Who is wrong? Let's check it now. What is the maximum displacement of any point on your rope? Should not be more than 14 centimeter. Am I right? Should not be more than 14 centimeter because that's the maximum. That's what superposition principle tells here. Now, if you pick up this, due to standing wave, it will be 12. Due to traveling wave, it will be 2. So maximum displacement 12 plus 12, 14. Or minus 12 minus 2, 14. Plus 12 plus 2, 14. But here you look at this one. 16 minus 2, 14. But plus 16 plus 2 will become 18, no? Sir, how come the negative sign? But sign, what is the sign? Sign is a harmonic function. It can take positive and negative value. When this is plus 16 plus 2, it will become 18, no? Minus 16 minus 2, it will become 18. So if you look at this, so what? It will not obey the superposition principle. What is superposition principle? Nothing but law of conservation of energy principle. Here, energy will get violated. So therefore, this is the wrong one. I'm giving some explanation here. That is what. Are you getting no? So why this is wrong? So I should definitely say that. If any reason for this will not obey. Some other color will not obey law of conservation of energy, because the displacement of any point in a rope cannot be more than 14, but here it is happening more than 14. So this is wrong. So this is what correct here. Okay, let's get into this one. Now, what is the, these are the nodes, no? These are the nodes. All of you, please do look. It's a very good problem for students to learn. And green color, I'll put antinode. No, antinode, what happened? Can have displacement due to standing wave and also due to traveling wave, no? So what is the maximum amplitude of antinode? For antinode, we'll discuss the thing. Antinodes. So what is the maximum displacement? Maximum displacement should be equal to how much?
Sir,
Uh,
sir, can you explain why second equation will not obey?
I'm not hearing much clearly.
Sir,
SSS.
why second equation will not obey, sir?
Second equation, what is the maximum displacement of any point on a rope will be 16. This sign can be negative also, no? The negative will become positive. 16 plus 2, 18. But what is the maximum permitted displacement according to superposition principle? Should be 14. Now, sir, what happens if it is more than 14? The will amplitude will determine the energy? Yes. Then you are saying that indirectly the energy is more than what we supply. What all energy on the rope is due to incident as well as reflected, no? So you are saying that no, energy will be more than the energy supplied. So we are violating law of conservation of energy principle. See, 8 plus 16, 14. But here what happened? Sign can be negative also at one instant. So then 16 minus of minus 2 will become 18. So the displacement of any point in a rope should not be more than sum of these two. So therefore, this will violate law of conservation of energy principle. Okay, got it? Okay, now what is antinode maximum displacement? 12 plus 2, 14. What is the minimum displacement? I think minimum displacement, they can be a test, no? So Y max, I'll write it. This is nothing but Y max. What about minimum? Minimum will be 0 because they can be, a, oh, this is, A max is asking. This will be maximum displacement of antinode will be 14 centimeter. Then will there be antinode at rest? Not possible. Antinode should vibrate. Okay, now as antinode vibrates, so what is the maximum speed of the antinode? Should be A max into omega. What is the minimum speed of antinode? I think when antinode is at rest, at extreme point, it will be at rest, no? So there's a minimum speed. Similarly, let's come for node. What is the maximum displacement of node? Anybody wants to answer? Due to standing wave, it will be 0. But along with the standing wave, a traveling wave is also set up, no? And we know when a traveling wave moves on a string, all points should vibrate on a rope. All points on a string should vibrate. Then what is the maximum displacement of a point on a string due to traveling wave? Equal to amplitude of traveling wave. What is the amplitude of traveling wave? 2 centimeter. So therefore, the nodes which we are supposed to be at rest, no, they'll also start vibrating. So then what is the maximum displacement? Will be 2 centimeter. Then V max. A max dash, you write it. This will be A max dash into omega. Minimum velocity of node will be 0 because the nodes, what happen when they're vibrating, when they're at the extreme point, they'll be at rest. So what about nodes? Nodes are a points on a string which should be at rest all the time. Maybe if the two waves of same amplitude undergo superposition, yes, it can happen. When two waves of different amplitude, if they undergo superposition, then the nodes also will vibrate. So because of traveling wave, the nodes also will vibrate. So what is the reason? We'll write it. Because of traveling wave on a string, nodes also vibrate with amplitude equal to amplitude of. Okay, this is very important. So when they're vibrating at extreme point, minimum speed will be there. Net power flowing through the node is asking power. So previous problem we have concluded, no, the net flow of power through a node should be 0. But here what I'm saying, I'm asking power. What is the power of traveling wave? That should be the, what is the power of a traveling wave? That should be the watt, like the power flowing through a node. So I'll go for the next part of the problem. Fourth one, I will keep like this. It'll be easy for me to write. Power flowing through a node. Power how to calculate this power flowing through a node. What is the expression for power? We'll write mu omega square. What is amplitude? Amplitude will be 2 centimeter whole square V by 2. This much is what we have here. Then we know K equal to 2 pi by lambda. Power is asking, am I right? The amplitude is 2. If you want to write it 2 square, you write it as 4. That will get 1. Can you hear me? Can you hear me?
Yes, sir.
Okay, that one, yeah. So this will become 2 mu square omega square V. Then if you want to replace anything V, no, V you can write it as omega by K. This V, what you can write it as okay, I agree this. There's a value 2 mu square omega cube by K. If you want to express in terms of rho density, something is given, you can express here. Now, how much of energy confined in one loop? Because standing wave is set up, no? So I want the energy, how much of energy present in one loop. How to calculate that? Anybody? Integration will be very lengthy. So what shall we do? We'll go for the earlier method of finding out the energy. I think what all energy that is there on the rope, it will be due to what? Due to incident wave as well as reflected wave. I'll go back to again. So the incident wave will have amplitude of how much? 8 centimeter. The reflected wave, so what all energy is sum of these two? So shall we write here now? Total energy in one loop is asking. So energy in one loop. Shall I write lambda or energy in one loop? Should be equal to energy density. Should be equal to rho omega square A1 square. I'll write it. Amplitude A1. This is A1 square V by 2. Okay, this should not be there, no? I'll do one thing. E1 plus E2 into volume of one loop. What is the length of the loop? Into area of cross section. This will be rho omega square A1 square by 2 rho omega square A2 square by 2. What is the one length of the loop? Will be lambda by 2 into S. So rho into S, will write it as mu. E is equal to rho omega square lambda by 4. Let me write all nearby. S omega square lambda by 4. What is rho into S? We'll write as mu omega square. Lambda, what we can write 2 pi by K. A1 square, 8 square, 6 square. So this will become 50 pi mu omega square by k. This is energy confined in one loop. Please, if you want, what is the mu? Mu is the linear mass density of the rope. If they give density area of cross-section, express in terms of that. What is the total energy on a string means? What shall I write? Into L instead of length of the loop, one loop. So what is that? They should be the lambda by 2, no? So if you want total energy on a string, so better use this formula. I think this will be best formula available for you. Energy density into volume of a string. How much of energy is confined in one loop? We have this particular formula. So amplitude, same amplitude, let it be different. Okay, it doesn't matter. Anybody having? So now what we have a standing wave where the nodes also can vibrate. If the two traveling waves of different amplitude undergo superposition, then what happens? The nodes also undergo displacement. If two traveling waves of same amplitude undergo displacement, the nodes will not vibrate. This is a conclusion. Hope you can remember how to calculate energy in all aspects I'm showing. You have to be very careful of mathematics, mathematically correct, but physics wrong. Mathematically and according to physics, it is correct. There's nothing wrong. Mathematically, it is correct, but according to physics, it is wrong. No point on a string should not have cannot have a displacement greater than 14 centimeter. That's what superposition principle, no? That's why this is wrong. Will not obey law of conservation of energy principle. Any reason for that? The displacement of a point on a rope can become more than 14, which is not possible. If you want, I'll write it. The displacement of any point on a string can be which is not possible. Okay. I'm writing all the reason not possible. This is okay. I agreed this one. So these are the some energy aspect. I just brought some nearly 3-4 problems. Let's go for next one. This question is not available in book. That's why I had to write it on my own. Let's go for sonometer.